Good day, everyone. In this presentation, we are factoring. In this lesson, we will factor in various ways. We're going to talk about what is a polynomial, and we're going to have various factor methods. Now, be aware, this is going to be a difficult lesson, simply because of the many layers has to be part of this. So I do caution you in particular to pause the video as often as you need, rewind, and redo. That's the only way you're going to get better in this presentation. Alright, so before we go anywhere into the lesson, we got to know the importance of what is a polynomial. A polynomial is an expression that can have multiple terms, such as what you see in the chart. It could have one term, which is a monomial. It could have two terms, which is a binomial. Three terms is a trinomial. And the fourth term, or three or more terms, let me say that, it's a polynomial. Polynomial is a term, many terms. It could be 5 terms, 6 terms, 7 terms, 8 terms, 9 terms. Anything more than 3 is considered a polynomial. Alright, are we good on that? Good. Alright, now the details of the polynomial is that the exponents of the polynomial have to have at least a degree of 0. For example, 5. 5 can be rewritten as 5x to the power of 0, which is equivalent to 5. Alright? And that's with any real number. 7x, 0 is understood to be just 7. And remember, as I was telling you guys in the beginning, when we was dividing polynomials like this, that 1 minus 1 equals x to the power of 0. So therefore it's going to be 1. But don't forget you have 2. So 2 times 1 is just 2. Again, I did this with the purpose so you guys can know anything to the power of 0 equals 1. Anything to the power of 0 equals 1. 9x to the power of 0 is understood to be 9. 10x to the power of 0 equals to 10. 1000x to the power of 0 is just 1000x. So you guys get the picture. And that is called a constant. Anything with the degree of 1. When you see a letter by itself like X, Y, Z, T, think of any letter of the alphabet. It always going to have a degree of 1. You're going to have a degree of 1, a degree of 1. It's all going to have a degree of 1. Any letter by itself has a degree of 1. Alright? Now, if we look at the exponent of 2, that's a binomial. But throughout the school year, we have to pay close attention to that binomial with the exponent of 2, because there's going to be a specific name for a function with the exponent of 2 or an expression with the exponent of 2. The last one, when you see anything to the power of n, I'm just saying any number. N could be 5, 6, 7, 8, you put the number in. So again, leading exponents. The leading exponents is always the biggest one. All right? And later, we're going to see all that into play. All right, let us proceed. All right, so in this lesson, it's going to escalate from easy to hard. So right now, we're just starting the easy stuff. So it's as if you are going to be climbing a tall mountain. And that's how hard the lesson is going to feel today. So just be with it. I'm cheering you on. And let's just get through with it, all right? Good. All right, let's factor this. And we did this in class. So I'm not asking you to find the sum. No. You got 6 plus 14. I'm asking you what is the greatest common factor of 6 and 14. So in case you forgot how to do that, let's just go through with it. We know that 1 and 6 is a factor. And we also know that 2 and 3 is a factor. For 7 is going to be 14 is going to be 1 and 14. And 2 and 7. What is the greatest factor that they both have in common? The greatest. The biggest number that they both have is 2. You write your answer as 2, 3. Because 2 times 3 is 6. But also 2 times a positive 7 gives you 14. All right, so far so good. We're doing pretty good. All right, so now let's get to a little medium one. So this time we got to pull out the greatest common factors again. We know that 4 is going to be the GCL for both of them because 4 times 3 is 12 and 4 times 1 is 4. So when we factor, it's going to be 4. That's why I'm taking it out. That's the GCF that you're going to put at in case you didn't understand how I did the last problem. The GCF is 4. And now you're going to put down what gives you the inside of this. So 4 times 3x gives me 12. But also 4 times 1 gives me 4. So therefore, I got this. Not bad, eh? All right. So we are about to climb the mountain. Start climbing. We was walking the path, now things just escalate. And again, I caution you guys to rewind the video, play it over again, do what you must to make sure that you understand what you are doing. All right. So now we are at the level 1. Starts off pretty easy, similar to the other problem. So we know that the greatest common factor of this is 5. But what else do they have in common? They both have a x in common. They have an x there and an x there. So 5x is going to be your greatest common factor. So 5x is on the outside because I know that 5x times 1 is going to give me 5x. But I also know that 5x times 5 is going to give me 25x. Again, this is my GCF. Now, be careful with this. The methods are going to start changing, so it's going to be more involved more in depth. It's not going to be as easy as it has been so far. So far it's been looking at the greatest common factor and placing it on the outside and then leaving what's left on the inside. Now, let me ask a question. With this particular problem, I want to know what type of polynomial it is. What type of polynomial it is. It is a binomial with a degree of 1. Now, before I continue, I know some of you are like, Miss Howard, why you write like this? You write, your handwriting is terrible. The reason why my handwriting is temporarily bad at this moment is as I try to write these notes into all of this, my stylus is acting strange. So I do apologize, but we should know that the type of polynomial that we have is a binomial with the degree of 1. And how we know that? Because the x's that we see has an exponent of 1. Any letter, again, by itself has an exponent of 1. T has an exponent of 1. H has an exponent of 1. Your initials has an exponent of 1. Theodore Howard, that's an exponent of 1. Alright. I think we're good. So let's move on. Alright. Now this is where things get a little interesting. So this is when the layers start coming about. So when you're looking at this binomial, you notice that it has an exponent of 2. Not 1, but exponent of 2. So before we deal with those exponents, let's just do the greatest common factor like we've been doing. So we both know the greatest common factor of this is going to be 12. Alright, so we know we could have 12 in the outside, because 12 times x squared gives me 12x. And also 12 times a negative 3x gives me 36. Alright, I'm not done here. I just want you guys to know I am not finished. I'm not done at all. This is the layers I've been telling you about. It starts off like this, like we did in level 0. But now the level 1s, you got to kind of add a particular step to it. So let's look at the exponents in this parentheses. It has an exponent of 2 right here. And this negative 3x has an exponent of what? An exponent of 1. Because any letters we see, like your initials, has an exponent of 1. So we do understand that. Sorry about that. So with that being said, let's move further. So in this parentheses, what do they both have? Now, it's easy to say, well, they both have an x to the power of 2, but if you look at this, you see an x power of 2 right here, but you see only an x right here, so you cannot say that they both have 2 x's. Both of these have 1x. Because they both have 1x, you could take out 1x from both of them. So when you rewrite this, your greatest common factor is now going to be 12x. what's going to be in the inside. So 12x times another x is going to be 12x squared. Because when you multiply exponents, do not forget, you add them, and do not forget that any x or a letter has an exponent of 1. So 1 plus 1 equals 2. Keep that in mind, y'all. Alright, so because I pulled an x out from the right hand side, I'm only left with 3. I'm left with a 3. Well, negative 3. Again, when you are factoring like this, you're always going to go for the smallest x that they both have. Like in this problem, they both have at least one single x. Alright? So let's keep this in mind as we venture on. Alright. Now, now we got some stuff to deal with. We got some drama to deal with. Now, oh my God, Mr. Howard, how am I supposed to handle this? Well, ask yourself this. What is the greatest common factor of 35 and 36? Well, they both have a negative 1 in common. Now, I know some of you guys will be like, what, Mr. Howard? Why can't I just say negative 1x squared? Because that's the smallest x that they both have in common. That is fine and whatnot, but again, everyone is on a different level of mathematics. So I'm not going to go like that. So the greatest common number factor is negative 1. So with that being said, negative 1 with the parentheses of 35 x squared, because I know that negative 1 times a partial 35x squared is going to be a negative 35x squared plus 36 cube. So I know that negative 1 times a positive 36 cube is going to give me a negative 36 cube. Now, let's look at our variables here. You look for the smallest x squared that the smallest x that they have, which, like I was unintentionally trying to say, they both have at least an x2 in common, because you have an x2 here for 35 plus 36. You got 3 x's here. You can't subtract 3 x's here, on both sides of this expression, because over here I only have 2, but on the right hand side I have 3. So because of that, I can take only just 2. And with that being said, my greatest factor of that is x to the power of 2. So it's going to be negative 1x squared plus, times 35x. Well, there ain't no 35x plus 35 plus 36x. Now, you can rewrite this if you want to. You could rewrite this as negative x squared times 36x plus 35. Either of these answers are doable. They fine. Now, why did I write it like that? The reason why I wrote it like this is because when you deal with polynomials, and again, if you feel like I'm moving too fast, just go back and replay the video. Because usually we like to go x3, x2, x1 plus a constant, x2, plus x1 plus constant x1 plus c. We usually prefer to go in the order like that, but as long as you could rewrite it so that when you multiply your stuff is still the same, it's just, put it in different places, it can work. You don't have to do it like that, but that's fine. All right, so we started off with factoring like we did in middle school, and then we added some factoring methods. Added some exponentials, because again, polynomials deal with exponentials. So exponents, exponents, not exponentials. So polynomials deal with exponents that has to be greater than or equal to 0. So now we're going to go a little bit deeper into this. So that was binomials that we dealt with. Now we're going to deal with trinomials. So it starts off like this. So going back to level 1, when you're dealing with a trinomial, this is a trinomial. Tri means 3. Again, I do apologize about my stuff, but I know that by you hearing my voice, you can understand that this says trinomial. So this is a trinomial. So let's go back to do what we did in level 1. So in level 1, we look for the greatest common factor of 3, 6, and 9, which is just 3 is the greatest common factor. And what's on the inside is going to be x squared, because 3 times x squared is 3x squared, plus 3 times 2x gives me 6x. And I also know that 3 times 3 gives me 9. And I'm done with that. Starting off. Now, this is by GCF. Now, please be aware that when we go through Algebra 2, we're going to have to do something extra with that. All right? Whatever's inside the parentheses, we're going to do extra stuff to it. Right now, this is okay for a level 2 easy. So let's do the level 2 medium problem. It looks similar to what we did with the level 2 easy, but we don't have nothing coming at all 3 turns. 3 could possibly go into 54, and you could divide that to find that out. But the problem is, you got no GCF of that in the front. In front of the x squared, the coefficient. Because we know between these two, 54 and 3 is going to be 18. But it had to be coming at all 3 turns. It'll be coming here, here, and here. But we don't have it. But you do have a 1. 1 is, but you're looking for more than just 1. If it's just 1, it simply won't do for this trinomial. So for this trinomial that you're dealing with, you gotta figure out what two numbers multiply together gives you negative 54. And then those same two numbers, when you add them, gonna give you a 3. So let's do it. I know that negative 6 times 9 gives me a negative 54. But I also know that if I owe someone $6, but if I pay them 9, I'm gonna get $3 back. So therefore, my answers should look as x minus 6, x plus 9. Oh wow, what is that? You guys, this is factoring in Algebra 1 for those who remember the Algebra 1. But again, y'all, please don't give up. Please don't get mad. Please don't flash out. Because again, math is not easy at all, and we are dealing with it right now. For those who feel like this is easy, kudos to you. But to those who do not, I implore you, do not get upset. Keep trying, keep going. Because when you're too busy getting upset and, stressing out, you lose. All right. We're going to do another factoring level 2 medium. And this is going to help because this is a trinomial with a linear exponent of 2. So anytime you got a trinomial with a linear exponent of 2, you have to take these particular steps, which is what two numbers, when you multiply together, gives you negative 108, but when you add them together, they give you a negative 3. So we could say negative 12 times a positive 9 gives me a negative 108. I hope I didn't say positive. If I did, I'm tripping. So let me repeat myself because I probably said positive, but I hope I didn't. So I know that negative 12 times 9 is negative 108. Okay? So I also know that if I add negative 12, meaning that I owe you 12, plus the $9 I did pay you back, I still owe you $3, which would be negative 3. So x minus 12, x plus 9. All right, just like that. Let me rewrite my 9 because I know some of you guys worry about my 9s. All right, so it looks exactly like that. All right, how you doing? How you doing? Hopefully you guys are doing good. Just remember, step at a time, y'all. Now let's get into something hard. Now this is the part that y'all like, oh my God. All right, and to make sure that it gets that's not as difficult, I make sure I put the plus signs all over. So yeah, what's the difference between this problem and the last problem we did other than the negative signs? You will realize that it has a number in the very, very, very front. Alright? So this method that we are dealing with is going to be called the swing method. And again, this method is called the swing method. All the steps we did in the level 2 medium is going to apply to this, but we got to do some additional steps. So let's do it. So step 1 in this one, multiply your coefficient right here times the coefficient in the back. So front times back, which is 10. Step 2, rewrite. So you're going to rewrite it, the expression, but you're going to add step 1 to the back. Now the rest of the steps, you're going to do exactly as you did previously. So again, with two numbers, multiply together gives you 10. And with the other two numbers, the same two numbers when you add, gives you 7. So 5 times 2 does give me 10, and 5 plus 2 gives me 7. Alright, are we good so far? Let me pause. All I did was multiply the front coefficient times the back coefficient, which gives me 10. Then I rewrote it here. I just got rid of the 2 in the front. And then that 5 in the back became 10 because I multiplied front times back. And then I did it so far with the rest of those steps. So x plus 5, x plus 2. Unfortunately, I'm not done yet. Almost. Like I told you guys before, when you come to a level 2 hard, you got to add additional steps. So when we do all that, you know your original front coefficient, which was 2, you're going to divide both integers by 2. So ask yourself this question. Does 5 divided by 2, does that give you an integer? No, it does not give you an integer. So in this case, your final answer for this first part, you're going to swing that 2 in the front and keep the 5 in the back. So when you divide 2 by 2, do you get an integer? Yeah, 2 divided by 2 is just 1. So you get x plus 1. And believe it or not, yeah, we are finished with this problem. I'm just trying to make sure I have some good stuff. Let me fix this a little bit. Try to clean up so you guys could, read my handwriting a little bit. Alright. Almost done here. So there. So again, rewind if you need. You know, we have successfully got through this part. It was a headache, I know. So let's move on. You are almost there. You are almost there. All right. All right, y'all. Take yourself some water. Get yourself a little break and come back to this video, because this is when it gets all very, very, very hard. All right. So yeah, level 3. This is all called factor by grouping multiple parts. So the first thing you want to do, because like you said, you want to group, let's group them in twos. Make sure you get the signs when you group them, all right? So in group 1, let's find out the greatest common factor of this. So the greatest common factor of this, when I factor this out, we know the GCF is going to be 2, and then it's going to be x plus 4. All right? So let's do the other group. The other group is 3x plus 12. What is the greatest common factor of this? 3 and x plus 4. All right. So you see how these match right here? They both match each other. So this is what you're going to do. You're going to put your matching answer at the back. And then the answers that don't match, like 2 and 3, just do 2 plus 3. And you are done. Not bad. Right? Not bad at all. But things about to get a little bit messy. All right. Now things about to get a little messy. The cool thing is we have things in order. So we have exponent of 3, 2, 1, and constant. We love it when it's in order because it's easy to work with. Just like you did before. Put them in groups. The greatest common factor of the first group is going to be just x squared. And what's going to be left inside of that is going to be x plus 4. Okay? That's group 1. Group 2, the greatest common factor of that is going to be 3. And it's going to be x plus 4 on the inside. Because again, I know going from the first group here, I know that x squared times x gives me x cubed. I know x squared times 4 gives me 4x squared. So I got that right. Now in my second group, we write that 3, so don't be so spaced apart. It's going to be 3 times x gives me 3x. I know 3 times 4 gives me 12. And so my stuff are matching. So it's going to be x plus 4 in the back and x squared plus 3. All right. All right. This is hard because you notice what's the difference between this problem and the other is that the exponents are not in the correct place. Well, we want the exponents to be 3, 2, 1, because your biggest exponent is 3. So x cubed should be in the front. So let's rewrite this. So x cubed plus 3x squared plus 2x plus 6. Bam. We wrote it. So now, let's do like we've been doing. Putting it all in groups. So let's look in group 1. What is the smallest thing that they have in common? The smallest, well, the greatest common factor is going to be only 1. But because we know 1, do we need to write 1? No. So what about the variable? They both have in group 1 an x squared. And we still consider that the greatest common factor because we're dealing with exponents in this case. And we know that x squared times x is x cubed, okay? And we also know that x squared times 3, positive 3, is 3x squared. Okay, so that's group 1. Let's do group 2. So group 2, the greatest common factor of that is going to be just 2. And then what's going to be left on the inside is x, because I know that 2 times x is 2x. And 2 times 3 gives me 6. I'm matching? Good. So my final answer is going to be in the back. It's going to be x squared plus 2. That is your final answer. But let me rewrite, because I want to make sure that it looks neat enough. I mean, I know I'm on a dealing with a wonky pen, but that's no excuse for illegible handwriting. Alright, y'all, we are done here. Woohoo! You have did it. You have stuck it out. You have endured all the hard stuff. Now, eat a cookie, go to the store, buy you some hot fries, and just relax, because you have endured it all. Now you're on top of the mountain, so celebrate hard. Congratulations, you did it.